Good morning, Norway! Good morning, students, and a particular welcome to all these students taking the Dynamics course with Helge Drange at the Geophysical Institute of the University of Bergen. My name is Morven Muilwijk and I'm a physical oceanographer of profession. However, today I am very far away from the ocean. I find myself in central Uganda, a small landlocked country in Eastern Africa near Lake Victoria. So why am I here today? I'm here today to talk to you about a very important concept in meteorology and oceanography called the Coriolis force. So as many of you might have learned, the Coriolis force is a very important concept when it comes to explaining large-scale weather systems and ocean currents. You might have wondered why tornadoes turn the way they do, why low-pressure systems rotate how they do, and why ocean currents almost always have a western boundary. This is all because of the Coriolis force. Now, the Coriolis force is an inertial force that acts on objects that are moving relative to a rotating frame. In our case, the rotating frame is the planet Earth. Now, for example, a water particle moving or air moving is affected by the Coriolis force. Now, as you might have learned, the Coriolis force acts differently on different places on the Earth. On the northern hemisphere, it acts towards the right of the direction of motion, while on the southern hemisphere, it acts on to the left of the direction of motion. On the equator, it actually has no effect at all. And this is why I am here today, because I am in Middle Central Africa, right at the equator, going to spice up Helge's boring or dry equations a bit with some fun experiments. So I find myself today exactly on the equator. As you can see, we are called the equator line. They've actually made some nice signs here and they draw the line. Where is it? The equator line. I'm at 0° latitude and going to do some very fun experiments with you. Actually, the road where I'm standing here, they've crossed a beautiful line where supposedly the equator is to be, as you can see. Now I'm going to do some very fun experiments together with a friend of mine to prove how the Coriolis force really works. Just going to introduce him. Alright, so to do the experiment, I have with me my friend here, Huntington. How are you? You are going to do the experiment for us and going to tell me what is going on.
Alright, so we are going to see what we call geographical water experiment. Now we are standing at the northern hemisphere side of the world. Northern hemisphere, if I pour water on top of this funnel here, water drains clockwise. Then the moment you cross it goes south, it drains anti-clockwise. Then right on the 0 latitude, there will be no movement. Water just drops straight down. That's
straight down.
So let me pour water here and see what's going to happen.
So we are now on the northern hemisphere.
Northern hemisphere side. That's been draining clockwise.
And it will be draining clockwise.
Then I have to neutralize, that's why I put this metal.
To make sure there's no spin in the water.
Spinning, exactly. Then after I remove the metal slowly, then after removing the metal, I drop this flower to show how exactly.
It's a nice whirlpool. And it is rotating clockwise. Beautiful.
Welcome. Now let's go south and see whether it will change. It goes the other way around. It's anti-clockwise the other side.
This is beautiful. He is really showing the Coriolis force in real life. So now walking maybe about 10 meters or so south of the equator.
South of the equator, now want to see whether it will change. It goes the other way around. It goes anti-clockwise movement. So let me pour water so I do the same thing as I did the other side.
We're now in the southern hemisphere.
I have to stabilize it. I have to make it calm down as I did the other side. Then after I move it slowly. Then after I put again the flower.
And it is rotating anti-clockwise.
direction.
Beautiful.
So the farther you move from the equator, that's the faster it goes.
The farther away from the equator, the faster it goes.
Now we need to put right on the 0 latitude and see what happens.
Let's move on to the 0 latitude. Isn't this amazing? This is real science. You cannot not believe this. I'm seeing it with my own eyes. The Coriolis force on the middle of the equator.
So 0 latitude line, where we won't see any movement. There'll be no clockwise, there'll be no anti-clockwise.
No rotation at all.
Yeah, I'm just stabilizing, make the water come down. Seeing that there is no any movement. Okay, then let's put our flower seed here.
And it's not rotating at all. Straight down.
Let's go straight down because we're exactly at the 0 latitude line. Alright, and then to be convinced,
Yes.
switch the balls.
We're going to switch the balls because are we completely convinced?
Exactly, and most welcome. We're gonna bring that funnel to the south. The one from the north goes to south, and the
Yes.
one from the south goes to the north. So let me pick it and see.
That's what we're gonna do. Just to make sure that this is not a trick, that this is actually
One can even
physics.
use the whole stand. Is it okay? Or
Yeah, we use the whole stand, I think.
Same water.
Same water,
Same stand. Same bath.
nothing special with the water on the northern hemisphere. Is this real physics or is it a trick? That's what we're now gonna see, because we're changing the balls.
Not enough. What is the flower? Let me put the flower in.
We need a new flower. So now we have the ball of the northern hemisphere on the southern hemisphere.
Exactly. So that's why we need to see now whether the water will change and goes the other way. Whether there's no trick, there's no drill, there's nothing.
So now it should go anti-clockwise.
Okay.
Isn't this exciting?
So let's put again
And it is rotating anti-clockwise.
direction.
Isn't it beautiful?
You're welcome. So now let's take this, the one from the south, the north.
Ball of the southern hemisphere, we're going to take it to the north. Only a couple meters. Just to prove that this man is a genius. Alright, so now we have the ball of the southern hemisphere on the northern hemisphere. Going to do exactly the same thing.
See that you got clockwise to stabilize also. Do the same
With
thing.
water.
Yeah. Make it calm down.
And it is definitely rotating clockwise. Isn't that beautiful?
So you want me to use the same one right on the 0 latitude also?
I think we believe you.
You're most welcome. Thank you very much. And then
Thank you very
we
much.
have 2 days a year. You know, we have March 21st,
Mhm.
September 23rd.
Yes.
That's what we call equinox, right in Uganda. You stand at the 0 latitude at midday, you have no shadow.
No shadow.
The sun is right above you.
And the equator is exactly here,
No.
on the meter.
It keeps on, you know, sometimes if you come with the GPS, sometimes it says it's 5 meters south.
Yes.
Sometimes it says 0, 0, so it keeps on, I don't know, maybe due to the earth. is moving.
So do you have to move your balls then?
Sometimes it refuses and move like 20 meters, 50 meters to get a spin. Just like
But today it is exactly in the middle.
most well, exactly.
So I'm a lucky man.
You're most welcome.
Thank you very much for your help. Thank you.
Nice meeting you.
This is my friend showing the Coriolis experiment in middle of Uganda.
You're welcome.
Thank you. So, the mystery is, I am here at the equator of Uganda trying to figure out the Equator Experiment. Is it a trick? Or is it the real physics that we're seeing? Who can tell? Are there anybody that has some good explanations of what I just witnessed. What can it be? Is it the ball? Is it the man? Is it physics? Or is it anything else? You tell me.